Today's topic is electrical safety. Whenever we talk about electrical safety, we always speak with reference to the Central Electricity Regulation measures relating to the safety and electric supply 2010. Seldom do we refer or mention National Electrical Code NEC for short as a reference document. I request Mahesh, please mute kindly. Others, please kindly mute. So what is the role of NEC in electrical safety? Well, that's a topic of to be heard today from a distinguished person today with us. The National Electrical Code of India is an all-inclusive electrical installation code prepared by Bureau of Indian Standards, providing guidelines for regulating electrical installation practices across India. The code was first formulated in 1985 and revised in 2011. The new code NEC of India 2023 has been released on 6th January 2023. It is a 764-page document with 8 parts and 49 sections. This new version is now kind of a Bible for electrical engineers on the basics of electrical safety. In fact, when the draft was released, our Department of Electrical Inspectorate from Kerala had given as many as 25 corrections or improved changes, suggestions, which has been incorporated into the document. So I think we can be proud to be a part in the formulation of this new code. To talk about NEC of India 2023, its role, its importance, and contents, we have with us a distinguished personality who has been actively involved in drafting the new code. Shri Gopakumar, yes, Managing Director of Cape Electric Chennai, is a very passionate person for whom electrical safety is close to his heart. His overwhelming desire to spread the concepts of electrical safety has made him a founder member and first president of the National Federation of Electrical Engineers for Safety to provide an impetus to the electrical safety consciousness in our country. Shri Gopakumar has over 28 years of experience in the field of electrical safety. More importantly, he was a member of working group in Select IEC, TC64, TC81, SC37A, and Bureau of Indian Standards, ETD 20, 30, 50, and National Building Code 2016. And this code also includes the formulation of this NEC of India 2023 code. And he's also, as I already mentioned, president of the National Federation of Engineers for Electrical Safety and a technical coordinator for Lightning Awareness and Research Center, Thiruvananthapuram. On behalf of National Safety Council, Kerala Chapter and HSC Forum, I extend a very warm welcome to Shri Gopakumar. We have so far with us 88 participants who have joined this webinar, 89 now. So I'm clicking to 90. So before Gopakumar takes over, I hope he reaches the 100 mark. I'm sure all of us would have great learning from him today. A 1 hour session is too short a period to talk about a 769-page document. But I'm sure you all would have a great learning and understanding about NEC 2023. I extend my affectionate welcome to all my fellow members and professionals to this webinar. And I'm sure you all gain immensely in the form of from this short duration talk. And together, we will work together for building a safe society and thereby a safer nation. I now invite Mr. Gopakumar to take over this session. Over to you, Mr. Gopakumar.
Hello. Good morning to everybody from London. So sitting in a hotel room. Here the time is 9:30. I think in India it's about 3 o'clock. I reached yesterday, so unfortunately I woke up in the morning 2 o'clock London time, and since then I was sitting in front of the computer and doing something. Anyway, once when we talk about this hotel rooms, actually electrical safety and hotel rooms are quite very much connected. So wherever I go, I always try to connect with electrical safety. One of the first item we take once when you step into a hotel is a pencil or a pen. I'm sure most of you, those who have stayed in a hotel, you know very well. in near to the telephone, normally in a hotel, a paper or a pencil, a pencil or a pen is kept. We take it, and the purpose? To put it into the third socket, earth pin of the plug, to the socket, to put our 2-pin plug into the socket. Otherwise, our plugs will not go. This is actually a very bad situation. Nowhere in the world this can happen. In UK, they have their national, designed their UK style plug, and if you have a socket, you can put it. Otherwise, you are out. You cannot put nothing like multi-pin socket. Anything goes inside, and finally this makes a lot of loose contact and the problem. So let me start the presentation. I hope my screen is visible to you.
Yeah, very much.
Yeah, thank you. You see, first, what we should understand that electrical safety is a subject which it is not related to, let's say, for example, one product or something which we can buy from the market. It is not like that. It is a complete effort of all products and services which is involved in an electrical installation. That means every product should have certain qualities, and everything together makes the installation safe and reliable. Similarly, it is not one person who can bring electrical safety into an installation. It's a combined effect of all people, those who are involved in the electrical, let it be the designer or the contractor or the person who does maintenance. Everybody comes into the picture once when we talk about electrical safety. One moment, I'm just skipping because I can see that. Sorry, my throat is not very well because I was traveling last few days. Like, yeah, now the screen is clear. So electrical safety is a subject which need a combined effect of all the products involved and all the people involved. Otherwise, we will not be able to achieve good electrical safety, safe installation. Now, today we are going to discuss about National Electrical Code of India, NEC 2023. Now, to show you about NEC 2023, I just opened the file. So here is a National Electrical Code of India 2023. It's a 764-page document. You can download it from BIS website. It's called as SP30. SP stands for special publication. It's not a normal, it's a special publication, and it's a code of practice. So when we tried the last time, the 2011 version, if we look, the name was National Electrical Code, but this time we made it National Electrical Code of India because few more nations are having National Electrical Code, and to distinguish our code, we have made as a National Electrical Code of India. Now, if you scroll down on the, yeah, here, the contents, it consists of totally 8 parts. Part 1 is applicable for every building, every electrical installation. Part 1 consists of 22 sections, starting with the scope of the code, then the definitions. This is the way most of the standards are made. Every standard starts with its scope. So before reading a standard, what we should do is read the scope and find out where it is applicable. This gives an very good information to the user that you are not misreading it. Sometimes, a product which is a standard which is made for outdoor application, if you try to apply it indoor, you will be in trouble. So first read the scope of the document. Then every standard goes with the same style, definitions, graphical symbols, and so on. Now, the technical subject starts from part 8 onwards, assessment of general characteristics of building. Then the wiring installation, part 10, 11, 12, 13 talks about protection for safety, shock, thermal effect, fault current or over current, and over voltage. Part 14 talks about short circuit and voltage drop. Like that, there are 22 sections. One of the important section is earthing, which is, according to me, very, very important, because most of, if you take 100 mistakes in an electrical installation, almost 50% are related to earthing. So here in this section, we have included simple pictures. It is not made as a standard, it's made as a guide, because people should understand and go through it properly. So these 22 sessions, and for example, section 17, erection and pre-commissioning testing of the installation. This is very much informative. Like that, if we look overall, all the 22 sessions together explains safety requirement in every electrical installation. Part 2 talks about diesel generators, and captive substation. That means this is specific. It is related to generators and transformers in an installation. If you don't have any generator, nothing to worry. This is not applicable. Part 3 talks about low voltage electrical installation requirements for special installation or location. Every application may have some special application. For example, residential purpose, something special. Swimming pools and fountains, something special. Medical location, something special, in the sense these are additional safety measures. So part 1 is applicable and part 3 is applicable over and above part 1. While reading the part 1 and part 3, you have to be very careful, because part 3 sometimes explains that clause number XXX of part 1 section 13 is not applicable, or it has to be read in a different way. So some simple explanations are there. This part consists of, again, 22 sessions. These special installations are like, for example, hotels, industrial, the electrical installation in furniture, operating and maintenance, gangways, something like that. Part 4 talks about electrical installation in industrial building. This is exclusively for industrial building. Then part 5 talks about public lighting installations, temporary outdoor installation and permanent outdoor installation. Part 6 talks about electrical installation in agriculture. 7 hazardous area, 8 solar PV. So these are the contents of the National Electrical Code. Please note that scope of National Electrical Code is everything after the point of commencement of supply. That means every electrical installation after the point of commencement of supply, means after the meter board. Give me one moment, please. So these are the contents of the code of practice. Now, how the code of practice is becoming mandatory, very important to understand. I'm just opening you the regulation called as Central Electricity Authority, measures relating to safety and electric supply, which is the regulation. I'm showing you on the screen the draft 2022, which is published on 28th July 2022. Sorry, this is published on January 2022. This regulation, actually the regulation talks about everything related to electricity, starting with generation, transmission, distribution, usage, and so on. Please note, NEC is applicable for after the point of commencement of supply. That means within the consumer premise. This consumer premise can be a house or a big complex or an industry or anything where people are using electricity. Similarly, consumers are now changing to prosumers. That means we produce and consume electricity. So everything which is related to an industry or a private person is included in NEC, whereas the regulation talks everything related to electricity, especially on safety. Example, generation, transmission, distribution, point of commencement of supply, and usage. Now, how we should read it is, I'm just taking you to the regulation number. Earlier, it was called as regulation number 12. Please note that this is a draft. This draft is already finalized, and most probably, I think the final draft will be published very soon. I'm just taking you to the old generation 12, but in the new generation, it is 14. General safety requirements. Read the regulation number 2. Save otherwise provided. I'm just highlighting this. Save otherwise provided in these regulations, the relevant Indian standard or National Electrical Code or National Building Code shall be followed to carry out purpose of these regulations. So basically, this regulation says the safety regulation has got certain purpose, which is nothing but base safety. Save otherwise provided, whatever not included in the regulation, you please refer to the relevant Indian standard or National Electrical Code or National Building Code. So if any subjects which is not included in the regulation, we are supposed to follow National Electrical Code. If IS standard is not available, international standards can be followed. International is nothing but IEC, ISO, and ITU. It is not American or British standard. IEC, ISO, and ITU. So if we read this particular part, the regulation 14, sub-regulation 2, it explains that for the purpose of safety, you are supposed to follow National Electrical Code. Now, this gives a legal validity. Here, in comparison to the old regulation, there is a big change. I'm just zooming, or I'm just highlighting shall. In the old regulation, it was may. May is a word which is not mandatory. So until now, in the old regulation, due to the word may, National Electrical Code was not mandatory, whereas in this case, due to the word shall, National Electrical Code has become a mandatory requirement. Number 3, material and apparatus used. Materials and apparatus used shall conform to the relevant specification of the Indian standard or National Electrical Code or international standard where relevant Indian standards are not available. So this also means, as I said, there is a definition for international standard. International is not like Pakistan or Bangladesh standard. This is IEC, ITU, or ISO standards. So basically, the products and the products which is used in an electrical installation shall be as per the Indian standard. So basically, these two regulations had changed the situation. I'm just scrolling down some more information. For example, regulation number 38. The new regulation 38. In this case, 38. Provision for supply and use of electricity in multi-storied building more than 15 meters height. Of course, you can see here, the owner or occupier of a multi-storied building shall ensure that electrical installation and works including works inside the building are carried out and maintained in such a manner as to prevent danger due to shock and fire hazard, and the installation is carried out in accordance with IS 732 and National Electrical Code. So this regulation, as I said, the regulation final most probably will be published within a month. So recently in one of the seminar in Delhi, the Central Electricity Authority officials, they informed that the English version is approved and they are translating it to Hindi, probably maybe a month. Now, this regulation gives a very clear indication that for buildings more than 15 meters height, NEC is mandatory or IS 732 is mandatory. Similarly, provided that hospitals and medical establishments shall have safety measure as per National Electrical Code, irrespective of height. So, very clear. Then, for example, the sub-regulation number 7, which talks about lightning protection, shall be as per IEC 62305. Electrical safety verification of the installation shall be done as per IS 732. In my view, all these new clauses are making a lot of change in the way the safety situation, or it is going to change the safety situation in India. Similarly, regulation number 43, the earlier regulation number 41, connection with the earth, which was, in my view, one of the most neglected or most confused regulation, 2 for neutral, 2 for body. But now it's very clearly made neutral conductor of a 3-phase 4-wire system and the middle conductor of a 2-phase 3-wire system shall be earthed as per IS 3043. So a lot of confusions are changed in this particular case. I will show you one more regulation and then go to my presentation. Now, regulation number 43, sub-regulation number 11. Earth fault loop impedance shall be tested to ensure the automatic disconnection of the protective device, and record of every earth test may be made and the result thereof shall be kept by the supplier. Please note, regulation is applicable for generation, transmission, distribution and usage. So this regulation is saying that the supplier shall keep the record of fault loop impedance. Unfortunately, we don't have the habit of testing fault loop impedance. Fault loop impedance not only become mandatory, it has become a responsibility of the electricity supply company. They are supposed to do the testing if there is a public electricity distribution, and they are supposed to keep it in their records for not less than 2 years. The next one, earth fault loop impedance of each circuit. Each circuit, the circuit belongs to the owner of the building. Regulation 11 talks about fault loop impedance test by the energy supplier if there is a public electricity distribution. Regulation 12 talks about fault loop impedance test of each circuit by the owner of the building and ensure that the disconnection time and the prospective touch voltages are lesser. Then regulation 13, where multiple sources are used in the same installation, example transformer and DG with changeover facility. Also, this is applicable if you have sources such as UPS, inverters and so on. Fault loop impedance shall be tested for both the sources and automatic disconnection of supply shall be ensured. So basically, these regulations are going to change the way, the current way of using electricity. A lot of new safety requirements are being included. Now let me go to the presentation. I hope my sound is clear.
Yeah, very clear, very clear.
Thank you. So we are going to talk about National Electrical Code of India. As I said, there are 2 parts. CA regulation 2023 is going to come out. It is no more 2022 draft, but we have to wait for next probably 10-15 days. Then the National Electrical Code of India. The advantage of NEC of India is it is in line with any wiring regulation of any other country. For example, the NFPA 70, NEC of USA, BS 7671, VD 100, and our IS 732 and NEC of India, all these are based on IEC 60364. IEC 60364 is the basic safety standard for design, erection, and testing of an electrical installation. Actually, I am in London today to attend a meeting of this IEC 60364 MT40. MT12, which is the maintenance group of experts responsible for maintaining the IEC 60364 Part 6 standard, which is the verification or safety audits. So today's news, almost every day, I am tracing at least 3 to 4 accidents across India. Yesterday's was major fire at Apple's supplier Foxling unit near Tirupati. I don't know whether you have seen this news or not. This is an electrical short circuit. The total loss is about 50 to 70 crores, and the managing director was telling that no casualty, nobody died. 300 people were rescued, and large part of the machinery and some cables were damaged, and a part of the structure collapsed. That means it's a major fire. This is on an average 3 to 4 accidents are happening daily. About 15,000 people, plus or minus a little bit, are dying every year due to electrical accidents all over India, which is an average of 700 plus people out of 100 million population per year, which is one of the leading death or cause of death in the world. In comparison, for example, Japan, the figure is 2 out of 100 million population per year. So we have 723 deaths, and in Japan, it's just 2. Please note that fatal accidents or minor accidents are never included in the this particular list. These are death accidents. Now to go back, every electrical installation need protection from electric shock, thermal effect, overcurrent, voltage disturbances such as fault, such as lightning, and so on. So these are the 4 mandatory safety requirements in an electrical installation. Now, to make safety against these hazards, lot of subjects are coming into picture. I am just going through few of the points. I will quickly go through it so that you will be able to understand the points. Probably the video is available for you on a later date to go through it so that it is clear for you. After every accident in India, the report always say accident is due to overload. Especially if it is a government organization, hospitals, the report always say the fire is due to overload. Actually, electrical engineers shall not use this word overload, because in the circuit we have so many protective devices. Protective devices, as I shown in the picture, there are MCCBs, there are MCBs, there are circuit breakers. All these protective devices are for the purpose of disconnecting the supply before an overload creates a problem. Instead of calling the fire due to overload, we should call as fire due to non-disconnection of the protective device within the specific time. In this subject, most of the time what we find is, please note that the protective devices are to protect the circuit, the wiring. Sometimes it is not to protect the equipment, it is to protect the wiring. Equipment will have its own protective device inside. This is the concept. For example, a motor, it doesn't have any protective device inside, then we are supposed to go for a motor starter, which is having protection inbuilt. So basically, these protective devices are protecting the wiring. Selection of wiring, selection of the protective device, type of the protective device are very much important. So there are tables included, especially in part 1, section 10. You can find these pictures. Also, please note that NEC has to be read along with IS 732. Lot of information in IS 732 we didn't reproduced in National Electrical Code. It always say you have to read the clause dash dash of IS 732. So you have to refer to IS 732 as well. Now, these pictures you can find, this explains you how to select the wire and how to select the protective device to ensure safety. MCBs, for example, there are 3 types of MCBs, B, C, D. Each one is having a typical protective curve, especially for instantaneous tripping. Type B trips within 0.1 second. If the current is more than 5 times its rated current. Similarly, type C 10 times, type B 20 times. Actually, these typings, for example, to protect your wiring, we are supposed to use type B MCB. So to protect a typical kind of equipment, we need you need sometimes C or D type of MCB. But for wiring protection, basically for, type B MCB is required. In contrast, the actual situation in the field is in some cities, or there are several cities in India where type B MCBs are not available to purchase across the counter. As a result, building owners go for type C, which is, you have to look at the characteristics of type C. The instantaneous tripping current is a little bit higher than or double than type B MCB, means we are going into a little bit on a dangerous situation. So selection of MCB is very much important. What I have seen is Kerala is the only state in India probably where type B MCB is still used for wiring in houses. Most of the other states, type B MCB is very rare in the market, and the sellers always sell type C MCB, which is actually not correct. Probably this is also one of the reason the number of accidents is little bit lesser in Kerala in comparison to other states. The wires.
Hello.
When
Gopal
it comes
sir.
to safety, not
Hello.
the
Hello, sir.
gentlemen, I
Yeah, sir,
request to
myself.
keep you mute.
Yeah, myself, Kallappa, sir.
Yeah, keep mute.
You can speak
ask the
once when the
later.
presentation is over.
Yeah, you can ask the questions at the end of the presentation. Request all the participants to keep your mic muted. Sorry, Mr. Gopakumar, you can proceed.
So now, once when it comes to the selection of wires, it is not the plastic, but it is the copper, which we have to be little bit more careful. Copper conductors, flexible wires, there are two type of copper conductors available. One is copper conductor class 2, another one is copper conductor class 5. Class 5 copper conductor is having little bit higher resistance, about 8 to 9% higher resistance in comparison to class 2 copper. That means class 5 is cheaper because class 2 has got little bit more copper, maybe pure copper. As a result, it is a little bit expensive. In the market, in several places in India, class 2 copper wires are not available across the counter. If you want, then you have to be an expert and you have to wait for a few weeks to get this material. This situation is not correct. The standard considered only class 2 copper conductor in all the calculations. Instead of class 2 copper conductor, if you use class 5 conductor, number one, it is illegal. Your installation is not confirming as per the National Electrical Code. Part 1, Section 17, Annexure B, there is a table included. Maximum allowed resistance of wires after pulling it through a conduit. Because while pulling, there can be chances of damages in the wire. After pulling it through the wire, we are supposed to measure the resistance of the wire and ensure that the continuity resistances are lesser than what is recommended in the table. In that table, the considered resistances of class 2 conductor. So the simple statement is, if you use class 5 copper conductor in your building, you cannot claim that your building is in compliance to National Electrical Code of India. We are also trying, once when the regulation is out, we also are trying to take it up with the electrical inspectorates across the country, every electrical inspectorate, and ask them to, or request them to write or make a notice, press note or something like that, to make awareness and tell people not to use class 5 copper conductor because of its cheapness or because of its less cost. All over India, class 5 copper conductors are used. As I said, it's a hazard. Please don't use class 5 copper wires. Disconnection time. Case number 2. Disconnection time means in case of any fault. Please note that there are two subjects, short circuit and earth fault. Wherever fault is mentioned means it's a earth fault. an insulation breakdown between a live conductor and earth is a fault, whereas a short circuit between current carrying conductors is called as nothing, short circuit over current or short circuit. So the disconnection time of an earth fault is very important because if the disconnection is taking more time, people may get electrocuted. In the picture, what you are seeing is you have a transformer, you have a kilowatt hour, means the point of commencement of supply, you have the fixed part of the installation, you have the final distribution circuit and a device connected to it. So at the final circuit, if you go for a TN system, 0.4 second, TT system 0.2 second, TN 5 seconds and TT 1 second, these are the maximum allowed disconnection times in case of a 230 volt supply. Sometime we also claim that our supply is 240 volt. In case of 240 volt, the disconnection times are even lesser. So how to ensure disconnection time? First, you should understand the kind of system earthing you are following. System earthing is classified into TNC, TNCS, TNS, TTIT. So it has to be understood very well. Each of the system works in a typical fashion. When it comes to earthing, the most confusing subject, which I always try to fight, 2 for neutral, 2 for body. Don't get confused due to the word earthing. It's just a term. It's just a term of making all metallic parts in your building at a potential equal to the earth potential. So the term earthing or earth, it has nothing to do with the earth electrode. 2 connections for neutral, 2 connections of body to the earth pit for UPS, for DG, for lift, for electronics. This is absolutely a big mistake. Please don't do it. System earthing is very much explained in the part 1, section 18 of National Electrical Code with very simple pictures to understand and very, very simple explanations. Why I said simple is, normally if you read a standard, the standard is like a legal document. Because in case of any litigation, in case of any confusion, it has to be referred without and read without any confusion. So you need a little bit expertise to read. Whereas NEC, probably for the first time, we have made it very simple because the idea is people should understand and follow it properly. You can also find these pictures in IS 3043. This picture is a changeover system. The picture in the standard is black and white. I just made it color. For example, the DG where I am rolling the cursor, I'm sure you are able to see that. It is the body of the DG is connected to a common bus bar. Incoming EB supply TNCS system connected to the same bus bar. Load side connected to the same bus bar. The same bus bar is connected to extraneous conductive parts such as pipe fittings or material, the frame of your building. Then independent earth electrode. This is not an earth pit in soil. Please understand. This is again a chassis earth. So this is the correct way of earthing. These pictures are already there in our electrical, in our standards IS 3043. For disconnection of a fault, we are supposed to use a protective device because finally this device should trip. There are 2 points. I have put case 3A and case 3B. 3A is automatic disconnection because the device should trip. And here the fault loop impedance comes into picture. Fault loop impedance is here where I'm moving the cursor. If you have a fault, the fault current is returning back to the source. Please note that fault current never go to earth. It will return back to the source. In this case, there is a metallic fault return path. As a result of the metallic fault return path, you have a very low impedance, a loop with a very low impedance. Now the impedance of this loop decide the amount of current which is flowing through the fault, and that particular current decide the disconnection time. It's very simple to understand. Simple Ohm's law. The IS 732 1989 has written very clearly that fault loop impedance shall be calculated, fault loop impedance shall be tested, fault loop impedance shall be verified during every electrical safety audit. Unfortunately, we don't do it even today, almost 32, 33 years now. So now, as I said, as I have shown in the CEA regulation, this clause is very clearly written. As a result, everybody, every electrician or every electrical engineer will be forced to do that. Maybe after a few years, instead of checking the earth pit resistance, everybody will start using or start checking the fault loop impedance. Please note that fault loop impedance is not the only test required. There are several, but probably I would say one of the important. In NEC, Part 1, Section 18, this table is included. This table tells you the maximum allowed fault loop impedance depending upon the type of MCB. For example, type C MCB, if you have a 63 amps MCB, type C MCB, the impedance of the circuit shall be lesser than 0.24 ohm. Now imagine, instead of a class 2 copper wire, if you use a class 5 copper wire, impedance is higher. Your MCBs won't trip. You are unfortunately, you are violating the requirements of the standard. Fault loop impedance shall be calculated during design, tested during erection and commissioning, checked periodically to ensure safe disconnection of supply. And the first job of an electrical safety auditor is to measure and cross-check this disconnection time. As I said, unfortunately, nowhere this is carried out. I have been doing electrical safety audits in several places. Wherever I go, I tell them that you don't need to do the earth pit resistance measurement. You are measuring earth pit resistance because of no knowledge. Don't do it. This is what you have to do. But most of the time, I have been kicked out. So the second part of automatic disconnection is called as protective equipotential bonding. I would say this is not the second part. If you look at the standard, what is written is protection against safety is achieved by protective equipotential bonding and automatic disconnection of supply. So protective equipotential bonding is preceding, that is the first one. It means every metal part in your building must be interconnected in such a way that the potential difference allowed within the building during a fault condition is maximum 50 volt. So very much important, protective equipotential bonding. You can think how many buildings in India this protective measure is included. IS 3043 since 1965 has explained this measure very, very clearly in the standard. Unfortunately, if you look at the design of an electrical installation, or if you look through the tender documents, you can always see that the electrical design is earthing is made as per IS 3043. IS 3043 is talking about equipotential bonding. It has given one picture of an earth pit in soil. If you read the content, you can be clear that the purpose of putting that picture is if you require an earth pit, you make it in that fashion. So it's not a mandatory thing. What is mandatory is this protective equipotential bonding. Case number 4. We use RCDs as a protection against direct or indirect contact. So situations are very much explained in the standard. Now, what is important in the new NEC is type of RCDs for typical application. There are 4 type of RCDs available: type AC, type A, type F, and type B. Type AC is where you expect sinusoidal leakage. Type A, sinusoidal plus pulsating leakage. Type F, sinusoidal plus pulsating plus a high frequency leakage. Type B is for smooth DC. These 4 RCDs are very categorically explained in the standard. Its explanations are provided. Now the difference is, for example, you have LED lights in your house or in your office, then you are supposed to use a type A RCD. It is not a type AC, type A. If you have solar PV installation in your rooftop, then you are supposed to, and the inverter doesn't have simple separation. That means there is no isolation transformer. In that case, you are supposed to use a type B RCD at the AC side of, at the incoming power supply of your house, for example. So these are very much included in the standard. If we look the overview of NEC with respect to products, a lot of new changes are going to come. Number one change is the resistance chart kicks out class 5 copper conductor from usage. If you use class 5, a copper wire with a class 5 copper conductor, then your building cannot have compliance with NEC. Similarly, if you use a type AC RCD for a circuit where you use LED lights, then of course you have no compliance. You have to be very careful while selecting. Number 4, again, the other kind of device, AFDD. You are aware that loose contacts and arcings are creating a lot of fire accidents in houses and industrial buildings. So these wordings, arc fault detection device, it's a device, a new device, which is actually disconnecting the supply in case of any arcing in the circuit. So these devices, shall be provided for single-phase AC system with an operating current not higher than 63 amps in premises with sleeping accommodation, in bedrooms, in habitant rooms, and so on. So basically, RCCB AFDDs are also getting mandatory in certain cases. So we have to actually go really deep into it, and we have to. I can explain you where this becomes mandatory, but not in this forum. Probably, it needs a lot of time. Case 5, protective conductor current, insulation, arcing, and fire and shock. If you look even the old, the regulation or the IE rule 1956 or the electricity rule 1937, all these rules, there was only one electrical safety requirement, which was nothing but the insulation resistance between live conductors and the earth. This means within the house or within the premise, within the electrical installation, the minimum required insulation resistance between current carrying conductors and the earth is 1 megaohm. We are supposed to test it every 5 years, regulation number 30, and we are supposed to keep the record. But all these things, we were trying to escape from that. We were not really making it. But in the new standard, it is very clearly written, the maximum allowed protective conductor current. So if there is an insulation degradation, there is a current flow through the protective conductor, means through the earth wire. So the maximum allowed protective conductor currents are mentioned. It is easy to follow. You have to follow certain rules very strictly to ensure that the current is lesser than the protective conductor. Now, this being the fact, probably one of the very important safety measure, there are products called as digital earthing system sold in the market. These digital earthing systems, the manufacturer claims that this is one-stop solution for all your earthing problems. If you read the catalog of these devices, you will see that this digital earthing or digital grounding system, it's a product directly from the God. That is the impression they try to create. If you use this kind of device in your building, these devices are making a short circuit between neutral and earth. Internally, they are shorting neutral and earth. As a result, a partial neutral current will go through the earth wire. These rules are completely destroyed, completely not complied. As a result, your building becomes in compliance with the standard. So please, if you have these dangerous devices such as digital grounding device, please disconnect it and throw it away immediately. It may be you must have spent a lot of time, a lot of money, but immaterial. If you want safety, you do it as quick as possible. Now, case number 6, let me go through it a little bit quickly. We are running a little bit short of time. This is about over voltage category. The next part included is with detailed information is about temporary over voltages in an installation. One of the classic example is in newspaper. Sometime I used to read transformer failed as a result, or the surge arrestor in the transformer is broken or failed. By the same time, several houses which is connected to this transformer electrical apparatus has failed, and in some houses there are fire accidents. These are due to phenomena called as temporary overvoltage. Explanations are very much included in the standard. You should follow it. The current loops has to be reduced. Let me skip these things. Case number 9, verification. Verification, as I said, NEC is talking about design, selection and erection, and verification. Verification is nothing but inspection and testing. We can simply call as auditing, or auditing is actually not the correct word. Auditing is a sampling method or a sampling process. You have 100 circuits and you select maybe 2-3 circuits and make an audit, which is not correct. At least for the first time, or at least once, you must do a verification of all the circuits. Here, verification consists of inspection and testing. There are 18-19 points for verification. Now I explain you only the first one, protection against electric shock. Protection against electric shock consists of basic protection and fault protection. There are several methods included or possible in a circuit. For example, insulation of live parts, barriers or enclosures, obstacles, placing out of reach. These are the basic protective measures. Fault protection. Fault is a condition. Once the basic insulation is failed, you go into a fault situation. So fault protection is achieved by these measures: automatic disconnection, extra low voltage separation, double insulation. For example, you have a solar PV installation, 400 volt or 600 volt on the DC side between positive and negative. So in the DC side of a solar PV installation, we are supposed to use the technique called as double insulation. Means from the solar PV terminal up to the inverter terminal, the minimum insulation requirement is 2. Sorry, one more. Double insulation is very much necessary. So the verification, the inspection part 1 in the previous slide, the method of protection against electric shock is the inspector should be aware of these protective measures, its applicability, its locations, where it is. For example, in a wet area, you may have to have one more protective measure. So the inspector should be aware of it, and he has to check whether these protective measures are appropriately applied in these areas. So like that, there are 18 or 19 inspections included in the standard. It is followed by testing. Testing, there are 10 testings included in the IS 732, but in NEC we have included one more, which is PAT 11th one, portable appliance test. So all these tests together, starting with the resistance of conductors, then insulation resistance of 230-400 volt system, insulation resistance of extra low voltage system, floor and wall resistance, impedance test, polarity test, effectiveness of automatic disconnection, effectiveness of additional protection. For example, if you look at effectiveness of automatic disconnection, it is not simply take a fault loop impedance meter, check the fault loop impedance and find out whether the MCB is tripping. That is 50% of the test. You also should test the effectiveness of automatic disconnection. So these are the 10 tests included, or 11 tests included in the National Electrical Code. If these tests are carried out as per the recommendation, as per the periodicity which is included in the Code of Practice, you can be 99.9% you can be sure that the chance of accident is rectified, or there is it's very, very rare. So instead of, rather than reading 2 accidents every day, we can make it probably 1 accident once in a month. So when it comes to testing, safety audits, actually most of the time the safety auditors, I'm so sorry, I'm not against any safety auditor, I'm making this statement just to ensure that everybody should follow a proper standard way of working. If one person goes in the left side and another person goes on the right side, we cannot work. So when it comes to safety audit, a lot of engineers think that making hotspot analysis or thermography will ensure safety. It is not. It is never included in the IEC 60364 Part 6 or IS 732 or National Electrical Code. These are actually extras. First you do the 18 inspection and 10 testings or plus 1, 11 testings, and over and above, whatever you want, you can do. So don't think that by doing thermography, you are safe. Case number 10, special installations. As I said, the special installations are bathrooms, swimming pools, solar PV, hospital, EV charging, extra low voltage. Each of these location require additional safety measure. For example, medical location, supplementary equipotential bonding, touch voltages are reduced to less than 25 volt. Find out the kind of appliance used. Find out whether these appliances are in compliance with the respective standard, whether they are tested in compliance to the respective standard, whether the maintenance is done while maintaining these devices, the requirements are complied. All these must be verified in a hospital environment. Unfortunately, I always make a statement that if there are 100 safety measures required, electrical safety measures required in one medical location, medical locations are classified into group 1 and group 2 medical location. Group 2 is a place where you have where the operation and those activities are happening. Imagine in a group 2 location, if 100 safety measures are required, I am yet to see a hospital, unfortunately, where at least 10 are maintained. You forget about 100, at least 10 are maintained is rare. That is the actual situation in our country. So medical location also require a lot of safety measures, lot of additional testings in addition to the one which I told, the 11 test. These are very much included. Part 3, section 9. So you can find it out. So with this, I would like to stop the presentation because we have almost passed 1 hour. Probably we can have a question answer session. Over to you, Mr. Nandakumar.
Yeah, thank you very much.
So
Mr.
thank you very
Gopakumar.
much. Thanks for
very much
thanks for all the
appreciate.
participants.
Yeah, I was expecting 150 plus. Expectation has been surpassed. We had about 155 people joining in various parts of not only Kerala, all parts of India as well. Speaks of your popularity as well, Mr. Gopakumar, in hearing your talk on electrical safety. And many thanks for joining from London. In spite of we were very particular to have you on this particular session because nobody can speak as authoritatively as you as far as NEC 2023 is concerned. So many thanks once again. And the floor is open for questions. I will quickly read some of the questions that have come on the chat box. How can we download NEC SP30 2023? I think maybe basic question.
Okay, this is very easy. You open Google, find out BIS sales portal. Then you get a link. Then open the BIS sales portal, create a username, password, and just download. It's free of cost.
Second one.
I will put the link also in the chat box.
Right, thanks. How do we calculate fault loop impedance manually?
You know the transformer size, you know the percentage impedance of the transformer, you know the length and size of the conductors, you calculate the resistance of all these together. The most important is you can calculate the resistance of the line conductor because we take it very carefully, whereas the return path, metallic return path resistance calculation is a little bit tricky. One of the reason is, for example, okay, I just put it on the chat box. You can click the link and you can buy the NEC. Or not buy, you can download. Indians can download free of cost, not for foreigners. Now coming back to the question, the fault return path, which is a metallic path, most of the time we use galvanized steel, nothing but GI. The steel which is considered in the standard is a grade 1, the high class, high quality steel. Unfortunately, GI which is available in the market is not the first quality steel. It is always the scrap steel. the recycled steel. Not one time, probably, recycled, again recycled, again recycled, several times it is recycled. And one of the last usage of the steel is in electrical installation as an earth return path. It won't work. You have to size at least 50% more than what is recommended in the standard. So, thank you.
One more question. Is there any criteria for source of emergency power? I believe.
Yes, of course.
Yeah.
Yes, very much. The source of emergency power, of course, very, very, very much, especially safety service. IS 732 part 5.6, clause 5.6 explains about the requirements of clause 5.5.6 explains about the requirements of the emergency, the source, alternate source for safety service. The changeover, that the type of the source is important, its capacity is important, its changeover time is important, and its reliability is important. And one more additional information what I can give you is these sources also can be of an unearthed system, IT system, which ensures even in case of a fault, the system need not have to trip. So, it's not a simple subject which I can explain over in 1 or 2 minutes. That is one of the big subject. Thanks for the question.
One more question, which was answered actually. Is NEC mandatory for factory?
Of course, yes. Wait for 10 more days. Once when the regulation is out, then once when the regulation is out, or if it is gazetted, then from that day onwards, NEC becomes mandatory.
I have class 5 cable conductor in my building. What is the alternate way to reduce the risk?
You have to reduce the size of the protective device. For example, if you are using for a typical application, if you are using a 16 amps MCB, you should try to reduce the size of the MCB to the next lower level. This means, you have another challenge of using the electricity, but if safety is the important subject, then you should do it.
One question that most of us face is how do we reduce the neutral to earth voltage?
Actually, this is also a misconception. Imagine you have a motor. The winding, single phase motor, the winding is inside. Between the winding and the body, you have an insulation of, let's say, few mega ohm, maybe tens of mega ohm. Let's say, for example, 10 mega ohm insulation resistance between the winding, which is nothing but the phase and neutral is connected, and the earth. Same is the situation with sometime a variable frequency drive, sometime with a UPS, sometime with electronic equipment, except the electronic equipment which require a functional earthing. Generally, between its protective earthing, means the body, and its current carrying conductors, the minimum insulation resistance is 1 mega ohm. Now, with such a high insulation resistance, even if the voltage between neutral and earth is 230 volt, nothing happens. Your equipment will not fail. The only exemption is if you have an electronic installation which is communicating. For example, you have an UPS, standalone UPS, nothing to worry. Let the neutral to earth voltage becomes 50 volt or 100 volt, nothing happens. Of course, more than 50 volt is a safety hazard. That is a secondary case. But theoretically, even if it is 230, nothing happens. But if your UPS is communicating, then there is a functional earthing. You can refer Part 1, Section 13 of National Electrical Code. These subjects are very well covered. So neutral to earth voltage is not a safety hazard at all. It is not a reliability hazard at all. It can be 5 volt, 10 volt, 20 volt, 30 volt. Technically, all our equipment are supposed to work even if the neutral to earth voltage is 230 volt. Thank you.
One question from Mr. Sushant KC. Can we connect lightning arrestor down conductor with MET together?
Actually, it is not can be connected. Must be
Can we
connected.
connect? Yeah. Yeah. Can we connect the lightning arrestor down conductor and MET together?
Yeah, the simple answer is must be connected. Otherwise, it won't work. There are
Most of the
pictures
time,
given in the standard.
there's the standard. Okay, thank you. Maybe a few more questions. Most of the time, electrical inspectorate state that NEC 2023 or any other code is not mandatory because it is not a law but code. So they put stress on following regulations. I think it has been again answered. We just we have
Actually, this we have to refer the old regulation 12 sub-regulation 2, which said may be followed. But now this may is changed to shall be followed. Once when shall comes, then it's a mandatory. In standards and codes, there are few words used: may, shall, recommend, and so on. Each of these word is having its importance. So shall is a mandatory requirement. So once when the new regulation is published or gazetted, then NEC becomes mandatory.
Thank you. A lot of questions on whether the presentation copy is available or recordings available. As far as a recording is concerned, this would be uploaded in YouTube, so it will be a reference to all those who want to have a refreshment or want to again go through the presentation done here today. Yeah. Earth electrode measurement has any importance or not in view of safety?
Yes, it's very much important for an earth electrode selling company. They have to do business now. Because all over India, this is, I would say, it's a disease, electrical safety disease called as chemical earth disease. People think that by putting chemical into the soil, you achieve everything, which is actually, sorry to use the word, it's an absolute nonsense. So the testing of earth pit has been removed from IS 732 or the National Electrical Code. You cannot find it anymore. So it's removed. You don't need to, with respect to the only case where you need to measure the earth pit resistance is for lightning protection earth electrode. Resistance, there are two methods explained, type A and type B. If you go for a type B earthing, type A earthing, each individual earth electrode shall have a value lesser than 10 ohm under the condition that the required length is not maintained in the soil. So if this statement which I made, if you develop it, there are so many technical contents. For example, type A, type B earth electrode, type A earth electrode, length of, there are vertical electrode, horizontal electrode, length of the electrode is mentioned in the standard. If you are maintaining that length, then you don't need to measure the earth pit resistance. If you are not maintaining the length according to the soil resistivity, then you are supposed to measure the earth electrode resistance and maintain it lesser than 10 ohm. That is how it is. Other than this application, there is no need of measuring the earth electrode resistance in a building low voltage where low voltage is used.
A few questions keeps coming. And maybe one last questions. Mr. Mohammed, earth rod shall be marked UL or EC? Material. What is that?
I think I already replied to that. It is up to you.
Yeah.
If you want a good quality, then of course, if you want an earth electrode, where it is required or not is a question. Second is, if you need one, then you go for an UL rated one because it is offering certain quality.
Thank you. I'm running out of time. One last question. Can you describe about the circulating neutral in case of connecting generator and transformer neutral?
Yeah. What you can do is, I would recommend to read the IS 732. Clause number 4.5, I think 4.5.2, where this subject is very clearly mentioned. Especially if you go for a changeover system between the transformer or a supply from a transformer and a DG, the conditions are very much explained. The circulating current shall not be allowed. The technique which is used worldwide is to go for a single point grounding. Single point grounding is the neutral is earthed only at one place, strictly only at one place. So as a result, the circulating current can be avoided. But please note that this answer is only one of the several answers I can make. The best way is, or maybe this subject alone, we have to discuss for 2 hours.
Right. Thank you very much, Mr. Gopakumar. I think we're running out of time. Other questions we can take it offline later. Many thanks for being with us today.
Mr. Nandakumar,
Yes,
Mr.
sir.
Nandakumar, I would like to take one question. The last question, Mr.
Yeah.
Sambasiva Rao asked, is ESE, early streamer emission method, is applicable in India or for LPS? Simple answer is absolutely not. Even the existing regulation number 12, sub-regulation number 3 says every product used in electrical installation for the purpose of safety must conform to IS or IEC standards. ESE is not as per IS or IEC standards. As a result, it is not complying. Legally, it's not valid. So thank you very much.
Okay, right. Thank you very much. Hope it's answered. Okay. Questions are keep coming. I think it's time to close the session. Many thanks, Mr. Gopakumar, for joining us from London on early morning, touching upon the very importance of NEC 2022, which is now getting mandatory once the CA regulation 2022 gets released in a couple of days, and also touching upon a lot of misconceptions that we electrical engineers harbor and practice. You have very aptly brought out and explained to you in very detail in a very short time period that you got to address us, and a lot many learnings today. It has been a good session to me, and I am definitely sure that everyone have benefited. I could see from the responses, a lot of thank you messages, excellent session and all coming up. Once again, on behalf of all the participants here, I thank you, Mr. Gopakumar, for the excellent talk that you have delivered, and hopefully we all practice it so that we get to a much more safer installations and homes and offices. Thank you very much once again.
Thank you. Thank you very much. See you.
And before we close, just a reminder of tomorrow's webinar talk is on QRA management decision making based on QRA by the CEO of Chola MS Rig Services, Mr. Subbarao. Please join. The links would be released soon. Thank you all for being with us today. Please do join us tomorrow also.
Thank you. Thank you, sir.
Thank you.